This presentation will discuss the geometry of the roots of the brachial plexus. Diffusion tensor imaging, otherwise known as DTI, is an MRI technique used to reconstruct the plexus in 3D. To produce the image, a step angle must be prescribed by the user. This is the turning angle between the connecting lines. Now, there's limited published literature to inform us on this clinical decision, so we conducted the following research. 10 embalmed cadavers were dissected posteriorly to expose the brachial plexus and spinal cord. We took photos and spatially collaborated them with MATLAB. The roots of the brachial plexus were traced from the dorsal root entry zone for 5 centimetres laterally using a Cartesian grid overlay. From the points connected by lines, we could resolve the step angle. So what did we find? Tortuosity increases from C5 to T1 with no significant difference between the left and right. The first thoracic root held the most tortuous course, and there was significant higher step angles and greater variability observed in the medial 2 centimetres of the roots of the brachial plexus. And that's where the dorsal and ventral rootlets coalesce, forming a spinal root. In our study, the majority of step angles were smaller than 20 degrees and less than 1% of step angles exceeded 70 degrees. The take-home messages from our study is that the overall complexity of the nerves increases as we descend from C5 to T1. Importantly, in terms of clinical decision-making, a step angle of 70 degrees is likely to accurately reconstruct 99% of DTI tractograms. Alternatively, the user can customize a step angle per root based on our findings. If you'd like to find out more, check out our paper in the Journal of Anatomy. Thanks for listening.